Hello everyone, Jorge Arteiro here from the Cloud Native Advocacy team at Microsoft. Today we're going to talk about Azure Files as a caching layer for the GitHub runners running on Azure Kubernetes Services. We're going to be able to run your self-hosted GitHub runners on Kubernetes using Actions controller. And we're going to show how to use Azure Files as a storage, a persistent storage, and you're going to use a .NET application and you're going to cache your NUGET package using Azure Files. You're also going to use Azure Files to generate ephemeral storage for your runners when they have to use containers, when they have some features on GitHub workflow, and you're going to go deep on that one. Let's get started. For this demo, I created a GitHub repository called Azure Files Actions AKS, where you're going to talk about Azure Premium File Share and also Action Runner Controller. Action Runner Controller is an implementation of a Kubernetes operator to orchestrate and scale self-hosted runners for GitHub Actions. Means your GitHub workflows will be running on Kubernetes, on Azure Kubernetes Services, and you'll be self-hosted by yourself. You're not going to be using the native GitHub runners, and there are a lot of use cases where you need your self-hosted runner to be running inside your virtual network, inside your Azure subscription, having access to your files. And you're going to use Azure Files to store some caching. In our example, I'm caching NUGET packages. NUGET packages are very common on .NET applications. I use it on .NET applications to cache packages. If using JavaScript, for example, it could be caching NPM files. Java could be Maven packages, and so on. And the whole idea is to install those components on AKS, the Action Runner Controller, that will be running on a namespace called ARC system, and also run a runner scale set that will be listening for your GitHub. You'll be connecting with GitHub and listening for your workflow runners. When a workflow requests a self-hosted runner to run the workflow, they'll be dynamically created, or you can have some pre-created as a cluster here running from 1 to as many as you want. And you'll be attaching a Azure File Premium Share with 100 gigabytes. That's the minimum that I can have now with SMB for Azure Premium Share. It'll be attaching on all the runners that scale set creates dynamically for us. And also for each one of those runners, we're going to attach an ephemeral disk, also using Azure Files, also using the premium, because you want to leverage the new Azure File metadata caching for Premium SMB file shares. That's in public preview. You have to sign up for the public preview. You have to click this link to sign up and also get all the information about those improvements on the File Share Premium SMB. Those improvements brings a lot of performance, as you're going to be able to see on this article. And then for create, open, delete, and close files, you're going to have a better performance and reduce metadata latency by 33% in average, IOPS by 65%, and network throughput by 63% when using this new public preview. There are some limits only on the regions that you can use. If you register for this public preview, you're going to have access to these new premium files with extra performance. I recommend you to try, give a go, and let us know what you think. And the whole idea is, how can we improve our performance when you're building using self-hosted runners? And using files as a cache mechanism, we can improve this performance. Pay attention one thing, Azure Files is the only storage available in Azure that allows us to do read, write many on Kubernetes. That means that you can attach this volume multiple times, as I'm doing here, 1, 2, and 3. The other ephemeral, you only attach it once, using read, write once, but this one for the caching, I can connect them multiple times, and I can keep all the caching On this volume, I'm going to show the one that I already created, where we have NUGET packages cached for us, and we don't have to download those packages from the internet. This file share will be mounted inside your self-host runner. Let's see how that works. Let's go step by step. On this repository, you have an installation folder with some YAML files that are going to be used, and you have also some documentations, the things that we creating inside the cluster, also the diagram, and all the screenshots from the resource that been created on your cluster. But let's go step by step on the main README file to see how that's done. Once you subscribe for the premium share, public preview, you need to install, make sure that you have Azure CLI, kubectl, and Helm. Those are the tools that you're going to use for this demo. Then we have to define some environment variables that we're going to be using on the scripts. When we run the scripts, the commands, we're going to use those environment variables. And those environment variables are the storage account resource group for the AKS and for the storage account that you're going to create for the file share, for the Azure File Share, the AKS cluster name that you want to create, also the storage account name, the storage account location, the region on Azure, and the GitHub config URL. GitHub config URL, you need to tell us which repository and which organization you are. In my case, for example, you'll be my repository, Jorge Arteiro, and Azure Files Actions AKS, that's my repository. Those other variables you don't really have to change. That's the namespace that you're going to use for the controller, you're going to use for the runner scale sets, and the name of the secrets as well. But you don't have to change, you can keep those already set here. But feel free to change. You have to change the repository that you're going to use for yourself, also the region, the name of the storage account, and the name of the cluster resource group. Once that's done, you can run this, copy here, you should be able to run on your command line and create those environment variables. The next step is run the AZ Azure command line, AKS creates, to create an Azure Kubernetes Service. On this command, we create a resource group, and we also create the Kubernetes cluster. We are using Azure Linux as a node for the AKS cluster. We say we need at least one node on the cluster, outscaling to 3 if requested. You can stick just with one. If you don't want to set the outscaler, you can remove this. And you can also set a different size. If you're going just to do a test, you can use a smaller VM as well. Otherwise, please keep the networking using Azure CNI overlay and set at least 100 max pods that can be created on each node on the cluster. Once you run this, you're going to have a cluster like I have here, one. This is a cluster, on AKS cluster. In my case, I have a little bit different configurations. You'll be able to connect. You can set your subscription, get the credentials. You also have those instructions here. You can get your credentials. If you have more than one subscription, make sure that you set the subscription. And if you don't have the command lines, AKS install CLI command, you can copy this and run here. They're going to install all the kubectl command line for you. I'm not going to do, I have already. And at the end, just to kubectl get nodes to make sure that you are connected. You have to run, before that, you have to make sure that you got your cluster credentials, and then you run kubectl get nodes. In my case, I set to have at least 2 nodes. Once you have the cluster created and have the connection for the cluster, I'm using WSL, Windows Subsystem for Linux. That's the way that all the scripts are using Bash and using Windows Subsystem for Linux. You can install this, that free, and you can create. In my case, I have Ubuntu 2404 installed. Then the next step is to create the Azure file. Once you create the Azure file, we need to create a storage account, and you have to make sure that we set the kind to be file store, and you have to set premium as the skill for your storage account. It will be a specific storage account just for file store. Then once it's done, we can get the connection string, and from the command line with the connection string, we can create the file share. And we're going to set 100 gigabytes. That's the minimum that we can do for premium. And then you're going to have these metadata like I have here created. In my case, I have created one terabyte. You have to create minimum 100 in your case. And then you can browse your file share. And then I have all the packages, and I'm going to show how is that populated. At the end, it will be complete empty. And once you run your workflow, they're going to populate for the first time all the caching that you need. The next step, once you have the AKS and the storage account and the file share created, let's now create the ARC runner controller. If you go on the documentation, you're going to see that they need to create this controller manage and also the listener that they call runner scale set listener. That's going to be creating dynamically the ephemeral runner sets. That's the self-hosted runners for GitHub. That's complete ephemeral. What ephemeral means? Means that they're going to run your job, and at the end, they're going to destroy this pod with your runner set, and you're going to create another one. Means that always going to be a fresh runner set when you run a workflow on GitHub. So you have to run this command using Helm to install the controller. And once you install this controller, if you go on workloads on the Azure portal on your AKS cluster, and you select a ARC system, you have a deployment now with your controller and one pod running for your controller with this one here, ARC controller. If you want to use the latest version, just remove this version from your command, and they're going always to use the latest version. Then we need now to create two secrets on Kubernetes. One for your storage key, and you can run this command to create the secret, and also for the GitHub app secret. If you don't have a GitHub app for your repository, you have to follow those instructions to create your GitHub app. If you go on your GitHub settings and you go on GitHub apps, you're going to see that they create a GitHub app called Arc Runner AKS. If you click configure, you're going to see something like that with your configuration. They ask you to at least give you metadata access and read-write access to administration. Then you can select only one repository. You don't have to do authorize for all repositories of your organization. In my case, I gave for those three, including the Azure Files AKS, Actions AKS. With that, we can get the secret using on that app, and you can run this command. They're going to give you that secret, and you have to make sure that you get your app ID and installation ID. That's mine. You have to get yours and create this secret. Once that create this secret, you're going to see also something like that created. Azure Storage Secret and GitHub Secret created on the Arc Runner namespace. Once that's done, we're going to create now the NUGET file share on your cluster. Then we have a couple files on the installation folder. We have one file specifically to create those PVCs. That's a YAML Kubernetes file that's going to create your 100 gigabytes file share. And the only change that you maybe have to do it is on the namespace if you change. Otherwise, you don't have to do it. But those are the attributes. We give you full access to the storage. And I also create this claim to be used on your deployment. So those are, like I showed on the YAML file, that maybe you have to change or not. And then you run this kubectl apply to apply this PV and PVC, and now you have the NUGET. Storage will be something like that, where you have, if you go on the storage folder, on your cluster, you're going to be able to see the persistent volume created called Azure File with 100 gig using that Azure File CSI Premium storage class and the persistent volume
once we deploy the runner scale set. Initially, you're going to see both there. We also need to create storage class to be able to create the dynamic volumes. If you remember here on the diagram, those three here are the dynamic ephemeral volumes. The difference is the first one we're not going to delete, not going to remove never this volume, because we're going to keep that as a caching, and the other ones will be running only by the lifetime of the self-host runner. As at the ephemeral, we're just running for one single job, and then will be deleted. Then for that, we want to make sure that we always delete those volumes created. Otherwise, you're going to, leaving rubbish on your storage account. For that, we're going to create separate storage class. I'm going to open here another separate. We're going to create two classes, one for premium and another for standard. If you don't want to use premium for some reason, you have the option to decide what you want to use. I recommend using premium because you can get all the leverage, all the caching, metadata caching performance. So you're going to create the storage account, the two storage accounts, and now you are able to create the runner scale set. And the runner scale set is going to use everything that you have created, secret, storage accounts, and so on. To be able to do that, we're going to use the runner scale set in a Kubernetes mode. There are different ways to install. We're going to use the Kubernetes mode, and we're going to mount the Azure file as a NUGET package caching, and also the ephemeral as a _work folder volume as well. And these, you have to decide which one of the classes you're going to use, and also the size. If you're going to use premium, minimum will be 100. If you're using not premium, you can have a smaller volume, like 5-10 gigabytes. The other parameters will be using the set option of the Helm chart. And that's the file that you can change the ARC runner set values on the install folder. This file here, you're going to be able to change some of those configurations, like you can replace the premium for this one, for the GitHub Azure file, but I recommend you to keep like that. And those are the configurations that you can change on that file specifically. We need to define also a pod spec for the runner. In case that we're going to use the container feature on the pipelines, is when you run your pipeline inside a container, your workflow inside a container is a specific GitHub feature. We have to define a pod spec, and there is another file that you have to create. You have to create a config map on Kubernetes, and that config map is another file where we define this pod spec. And the pod spec will be also mounted in the Azure file, and also mounting the work folder dynamically, but we have to make sure that we mount the Azure file on your .NUGET folder inside your runner. In this case, using containers, and we need that container definition that could be complete customized if you want. Once that pod spec config map is created, just run now the final step. That's run your Helm chart, and then things that you can change is, but you don't have to change anything, but you could customize minimum and maximum runners. Means that how many self-hosted runners you want to be waiting for your job. It could be 0 and it'll be dynamically created, only take 5 seconds or less. Or you could have like 2, 3, 5 runners waiting for the jobs. Up to you if you want to scale to 0 or if you want to keep some minimal runners, and you can also set the maximum number of runners waiting for jobs. And that's how you run. You copy this Helm command with all the settings. Again, this version has to align with the controller that you created before. They cannot run in different versions. That's why I'm setting the version to make sure that both are running always on the same version. If you remove this, they're going to get the latest version of the Helm chart that's on this OCI repository on GitHub itself. And I'm using the values that we customize as parameters for my Helm chart, and those settings I override some parameters as well of the chart. Once you run that, you're going to see on your cluster now this listener, and you're going to see the ARC runners. In my case, I set at least one running all the time. Then I have my runner running here. And what I have more, I have my volumes. That will be the dynamic volume created. And the NUGET Azure file, that will be the NUGET caching. Now I have two volumes mounted there. And if you look at the storage class that we create those two last storage accounts. And we're also using the Azure File CSI Premium. That's very well documented on this documentation page here. How you can use Azure Files CSI driver on AKS. That's installed by default. So with those storage running now and available, what's left for us? You can upgrade something on those runners if you have to. If you need to change any parameter, just run the Helm upgrade. And the last step is run your workflow. Get any workflow. On this repository, I have some examples. Okay, if you want to test the container service, and I'm running two pipelines here to build .NET. On this repository, I have a .NET application that you can use to test. And those pipelines, they are, let's open all three pipelines. And those pipelines are using the self-hosted runner that we define with this name. But you can also get as, I'm getting as a parameter. You have to trigger manually. I'm using workflow dispatch that you have to be triggered the workflow manually. And in this case, I'm using the container feature, and I'm using the .NET SDK to get my code, restore, build, and publish my .NET. But we could also do the same without container, without the container feature. Pay attention to that name here, container. That's when you run everything inside that container image. Or you could run inside the runner itself. In this case, I had to install .NET. I have to set up .NET. That takes a little bit longer. Then I can do the restore as well. I had to install curl because the setup.NET needs that. Or you can do something more fancy and test containers using like a Ubuntu container. Ubuntu container would just run a hello world, and you have a Redis cache as a service mounted as a container. And the funny thing, the way that runs on AKS is they create a pod with two containers, with your runner and with your service. And you could even run like testing here, anything that you want to run inside those pipelines. You should be able to do it because you now have a fully, supported container feature as well running on those self-hosted runners. So follow the instructions at the end. Make sure that you remove all the resource. If you are just testing, you can delete everything. And if you want to go further, you can also look at my second repository. I'm using not only Azure Files, but I'm replacing Azure Files for Azure Container Storage. That's a new service on Azure that give you a very fast performance because they're using the local disks on the Azure Kubernetes Service as your ephemeral NVMe disks. And then you have a very fast performance for those ephemeral disks here. And you have all the power of Azure Files that can be mounted multiple times to do caching that's never going to be deleted, and you'll be caching that forever. Let's run one pipeline to finish, or one of those pipelines. And to run a pipeline, you go on Actions, and I'm going to pick without container, and I'm going to trigger the pipeline manually. Keep is the name of my self-hosted agent. Once you run, they're going to dynamically create, they're going to use the self-host runner that's already there. As you can see the name of the runner, 57 TVX, and it's exactly the name of the runner that's 57 TVX. That's where your pipeline is running, your workflow is running. He creates a second one. Why? He creates a second one. Sorry, it's 57, but it's also 4ZR. 4ZR is this one. That's where the workflow is running. And the second one is created because they always keep it one available. We always keep one available. That's what they requested when you create the runner set. That's why the second one is created. And as you can see, another volume was created dynamically for the second runner that's there. Once this pipeline finished, this one will be completely removed and the volume will be removed as well. The pipeline is running, is installing, setup.net, and then restore your package in. And now, because we mounted the NUGET package, they're going to be a little bit faster to restore. They don't have to download all these files. They get the files now from that package here. And then the restore will be a little bit faster because they're just using the package in caching without have to restore. The way that I did, I put on our code a lot of, if you go on the CS project for this .NET application, I put a lot of packages here, just dump packages to get some load and show that we can have a better performance. And not just performance, if you don't want to always get from the internet, that's a good way to not be downloading from the internet those packages. You can download from the cache. And that's it. The pipeline is complete. And if you go back there on your runners, the runner will be very soon being terminated. And those volumes, let's refresh to see if the volume is still being used. Let's wait a second. And now you can see the was completely removed. The number 4 that was removed, and also the volume claim and volume was removed. That's pretty much how that works. If I go on my Visual Studio Code where I have the Kubernetes extension, I can access my cluster and you can see the pod. If I open the terminal for this specific ARC runner that's still running there on my cluster, I can verify that I can do a ls-al and I can see the NUGET folder be mounted there. I can do NUGET, I can see all the packages available inside my runner. That's how we cache the package. If you want to try the other pipeline using containers, so let's run this pipeline. It's going to take a little bit longer because using containers to run. Start running now. It's going to take some time to prepare. You can see the PXZ, that's the runner that's going to be running that, this one. Not one be again being created, to be always have one available for another job that may be request. That's how I did it. I set my configuration. And then the initialization container takes some time. Let's wait. This pipeline uses the container image from Microsoft.NET SDK 8, and this container will be created. And when this container will be created, they're going to use another container here called dash workflow for PSB dash workflow, a separate pod with this container that was requested. And that's where they're going to run your pipeline. And again, you're going to use that pod spec that we discussed, and we're going to mount the NUGET package there. The container being created, now we have a workflow container pipeline that start running now. Should be able to also see on my extension, we can open this extra container, the workflow one. The pipeline is running in there. It's very fast now. The container is running. And if you also look inside there, we have Ubuntu running. And if you go on the folder, we also have the .NUGET is already finished. You didn't have even time to look. It's already gone, and the pipeline is complete. It was very fast after the container being set, but we have been able to see the NUGET folder inside there, and because everything was cached, was very fast to build, and the container has been completely deleted, all the volumes being removed as well, and very soon we'll be back to one instance. In some seconds, you go back to a single instance, single pod waiting for the next job. That's how this works. If you are interested, I'm going to do another video also explaining how you can improve it even further and use the Azure Container Storage project to get complete ephemeral NVMe disks, local disks running on the nodes as ephemeral disks. This can go next step, and you can mix Azure Files and Azure Container Storage. There are some requirements that you need, like a cluster with a little bit with 3 nodes, and more, and the local disks as well, to be able to install the ephemeral disk and the NVMe extension, the Azure Container Storage extension. So you can follow this repository, and maybe I can bring another video explaining in details this second option here as well.
Just recapping here. Today we learn about how to get your self-hosted runners, and now you can use Azure Kubernetes Services with the actual runner controller to run all your self-hosted agents with access to your private network, and also using Azure Files as a caching layer for your NUGET package or NPM package, any kind of package that you want to use. And also we can use Azure Files as a ephemeral disk, like a temporary disk for your runners, for example, using containers. Hope you enjoy. See you next time. Please subscribe to the channel, follow us, hit the notification bell, and see you next time.